Alright, in this video we are going to cover the whole DMA 50 review. Feel free to scroll through the video to find the problems that you're trying to check. And let's go ahead and get started. Show your work. If the problem is a real-world application or word problem, write a complete sentence as your final answer. So don't forget that whenever you're solving a real-world problem. Number one, this pictograph shows projected sales of compact disc for a particular rock band for 7 consecutive years. Approximately how many fewer CDs will be sold in 2007 than in 2010? First of all, this pictograph, that CD, each CD represents 10,000 CDs. So we're focusing on 2010 and 2007 right now, since we want to find out how many fewer CDs will be sold in 2007 than in 2010. Well, how many CDs do you see in 2010? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 of those CDs, and you multiply that by 10,000, since each picture of a CD represents 10,000 CDs. Therefore, in 2010 you'll have, or they're projected to sell 100,000 CDs. Whereas in 2007 there's 3 of them, or 3 pictures of CDs. So let's multiply that by 10,000 and we get 30,000 there. So how many fewer will be sold in 2007 than in 2010? We want to find the difference between these two numbers. So 100,000 minus the 30,000, we get 70,000. So a complete sentence there, you can word this your own way, but we could say there will be 70,000 fewer CDs sold in 2007 versus 2010. Alright, so now number 2, using the pictograph above, which year is projected for having the least sales? Looking up here at the pictograph, you want to use the one that has the least number of CDs as a picture. So it's just asking for which year, and that year will be 2013. Notice all these other ones, we have more than 2 CDs in each picture. So therefore an answer there, we could say the year 2013 is projected to have the least sales. Alright, number 3. How many total CDs are projected to be sold in 2010, 2011, 2012, and 2013? How I'm going to tackle this. First of all, make sure you are looking at the correct years. So we want to focus on 2010, 2011, 2012, and 2013. Now what you can do is you can add up all these, or count all these CDs right here, and then multiply that by 10,000. Instead of doing this one times 10,000, then doing this one, and then doing this one, and then adding them up. Add up all your CDs first to do this a little bit quicker. So from 2010 to 2013, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We said that right there anyway. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So 27 times 10,000 CDs per picture. Therefore, we will the rock band is projected to sell 270,000 CDs. Let's put a complete sentence on that. There are 270,000 CDs projected to be sold in 2010, 2011, 2012, and 2013 combined, because we did combine all those together. Alright, on to number 4. So we're on to a bar graph. The bar graph below represents various colors of cars sold. Use the graph to answer the questions. Estimate the number of red cars sold. Now be careful, this y-axis right here says the number of cars sold in thousands. So that would be 10,000, 20,000, 30,000, and so forth. So estimate the number of red cars. We can just look on the chart. The red graph goes right up to about 60. So there will be an estimated amount or estimated number of 60,000 red cars sold. No math to do there really, no adding or subtracting. So on to number 5. Estimate how many more tan cars were sold than yellow cars. Tan cars. Tan looks to be right around the 30 mark, so we'll say 30,000. And yellow cars looks to be right around the 10,000 mark, or 10 mark, so we'll say 10,000. Let's subtract the 2, so we get 20,000. And our answer here, we can say there will be approximately 20,000 more tan cars sold than yellow cars. Just be careful, make sure you're reading the right color on the graph. Double checking, that was 30 and that was 10, so we're good there. Which color sold the closest to 30,000? Well, we just said the tan cars were right around 30,000. That's the closest one. So again, no math to do there. Just write a complete sentence. The tan colored cars sold the closest to 30,000 cars. Alright, number 7. Alright, the line graph below shows the price of a stock over the course of a day. Use the graph to answer the questions. So we have the price of a stock. For example, at 9 a.m. it was $2. Notice it says dollars. Looks like it peaked out around 1 p.m. at $9, and then it dropped some more over the course of the day. And then it closed at 6 o'clock that day at around $5. Just getting used to reading that line graph. Now I'm going to bold those lines, that way you can easily see that those are part of the line graph as well. So at what time, number 7, at what time was the stock price the lowest? The stock price was the lowest at 9 a.m. If you look on the graph, $2 is as low as it gets. Notice it rises, then drops some, but never drops below $2. We don't have to say $2 there, it just says at what time, so it was at 9 a.m. What happened between 11 a.m. and 12 p.m.? Did this happen between 2 consecutive time intervals at any other time during the day? Between 11 and 12, notice the stock price didn't change. It remained the same at $7. And even though it wasn't $7 over here from 4 to 5, it still stayed the same over the course of that hour. So what happened? We can say the stock price remained the same from 11 a.m. to 12 p.m. This also occurred, I can't spell, from, what do we say, 4 to 5. Two hours. All right, and what is the difference between the opening stock price at 9 a.m., it was $2, and the closing stock price at 6 p.m. It closed at 6 o'clock at $5. The difference between those is $3. So let's put that in a sentence. The difference between the opening and closing stock price is $3. And again, all that came from the line graph. All right, on to number 10. The circle graph shows the percent of the total population of 45,400 people, that looks kind of like a typo, of Springfield living in the given types of housing. So we have single families, duplexes, townhouses, condos, and apartments. Find the number of people who live in single family houses round your answer to the nearest whole number. So what we have here is 40% of the entire population of Springfield. 40% of them live in single-family houses. So we want to find 40% of the population, which is going to be 45,400 people. To do that, the word of means multiply, so we do 0.40 or 40%. Of means multiply 45,400. Now, you don't have to show all the multiplication here since you're already in DMA 50, but just show that you do recognize, hey, of means multiply, and then 40% of 45,400 people is 18,160. So let's write this in a sentence. There are 18,160 people living in single-family homes in Springfield. All right. Do we have another question for that one? No, number 10. All right, number 11. Find the slope of the line. One thing about this, though, there's no dots on this one, so I'm going to put some dots where it definitely seems like it crosses at a point. For example, right there, and it looks like it crosses the y-axis right there. So we'll use those two dots. There's some other places, too, where it definitely seems like it crosses, but I'm going to use those two, the x-intercept and the y-intercept. We're going to make the assumption that dots are right there. On the module exam, should we have one where the dots are not there obvious, I'll be sure to give that to you. But using these 2 points to find the slope, we can just do rise over run. So we go up 1, 2 units. Again, I'm doing rise over run. So if we go up 2, then we're going to go to the right, up 1, up 2, to the right, 1, 2, 3, 4, 5, 6, 7, to the right, 7. And now remember when I said up, that's a positive number. To the right, that's also a positive number. So the slope is 2/7. Number 12, you have a vertical line. Recall a vertical line. Vernox. The NO in vernox means there is no slope. Or you can say the slope is undefined. That's for a vertical line. Also, don't forget, though, maybe you will not have a vertical line on your module exam. Maybe you'll have a horizontal. So think about HOI. Should we have one of those? Look back at your notes for that material, too. All right, 13. Find the slope of the line containing the 2 given points. The formula for slope, you can either take y1 minus y2 over x1 minus x2, or you could take y2 minus y1 over x2 minus x1. Either formula works the same as long as you keep the y1 and the x1 first, or if you were to use the x2 and the y2 first. Don't be getting the x's and y's mixed up. I prefer to use this formula because I'm going to take the first y value minus the second y value. Therefore, we have negative 11 minus 18 using the formula. And this is divided by x1 minus x2. So 14 minus a negative 19. 14 minus a negative 19. Be careful right there. The reason why that minus is there is because the formula tells you to subtract it, and then you want to subtract what that number is in the x2 spot. So it is a negative 19. This becomes a plus, so therefore up top, negative 11 minus 18, that's going to be negative 29. Down here is where this becomes a plus, so actually you're going to take 14 plus 19, and 14 plus 19 is equal to 33. So there's the slope of that line that contains those 2 points. Number 14, find the slope of the line. The way I recommended doing this in class, if you have 2x plus 5y equals 26, I recommend getting y by itself. So let's go ahead and do that, and then we'll talk about why we did this. So we move the 2x over. They cancel out. 5y equals negative 2x plus 26. And then we divide everything by 5 to get y by itself. So we're looking at y equals negative 2/5 x plus 26/5. The reason why I recommend getting y by itself, a very popular form for the equation of a line, is y equals mx plus b. Whatever that number is in front of the x, in this case it's negative 2/5, that's the slope of the line. So therefore we can say the slope is equal to, or m is equal to, negative 2/5. That's the answer to number 14. Alright, 15. Find the slope or rate of change. Use the appropriate units. So this is like a real world problem. Let's make sure we use a complete sentence. And what we have is the number of years of use and the value of a car. So a brand new car, year 0, a brand new car, it didn't cost 20 bucks, it cost 20,000. So that's 0, 20,000. Whereas as the car gets used, the value depreciates. Notice this slope is negative. We're going down a mountain from left to right. So the coordinates of that point there, this other point we have on the line, is 5, comma, not 10, but 10,000. So we can find the slope using these 2 points, doing the same thing we did back here in this example, number 13. So we take y1 minus y2 over x1 minus x2. So let's plug in our values. It doesn't matter which one you call y1. If we call this y1, we got to call that x1. So just make sure whichever one you call x1 here, you make sure you call that y1. You don't want to say x1, y2. Just be careful there. So we'll call this the x1, y1. We'll call this the x2, y2. Alright, so our formula, 20,000 minus y2 is 10,000 over x1 minus x2, so that's 0 minus 5, and that is where our negative is going to come into play. 20,000 minus 10,000 is 10,000. Divided by 0 minus 5, that's negative 5. So when we divide this, we get negative 2,000. But now let's use the appropriate units and let's go ahead and put this in a sentence. What's really happening here is, because this is understood to be over 1, but we can just say negative 2,000. That means every year that we had this car, it drops $2,000. So for example, if it was worth 20,000 here, at year 1 it would be worth 18,000. Notice it is dropping, and it is right around 18,000 because we're losing $2,000 per year. So then, therefore, year 2, it would drop another $2,000, which would put you at 16,000. Year 3, it would drop another $2,000, which would put you at 14,000. Year 4, it drops another 2,000, which puts you at $12,000. And then year 5, we said we were down to 10 grand. So a complete sentence here for this one. Talking about the slope or the rate of change, the price of the car drops $2,000 per year. All right, number 16. Graph the equation by determining the missing values needed to plot the ordered pairs. So we want to fill in the missing values, and then we want to plot them and sketch the line. Here's our equation, x minus 2y equals negative 6. And since we have some missing values, I'm going to make a t-chart. Alright, so this means we want to plug in 0 for x. I'm going to do some scratch work over here to the side to make sure, and the more work you show for this type of problem, if you were to mess up on a sign or something, I could look at your scratch work and find out where you made a mistake. So the equation x minus 2y equals negative 6, we want to plug 0 into x. Therefore we have 0 minus 2y equals negative 6. 0 minus 2y is still negative 2y. And solving that equation, you get y is equal to 3. So we get 3 for that one. Okay? Just put my stars over here, keep it color coordinated, I guess. All right, another point. Something, comma, 0. That means we want to plug 0 into y. So therefore, going back to the equation, we have x minus 2y equals negative 6. If you plug 0 into the y spot, we now have x minus 2 times 0 is equal to negative 6. Notice I'm taking that 0, plugging it into the y spot in this equation. So x minus 2 times 0, well, that's x minus 0. That still gives us x is equal to negative 6. So we found that point. Let's keep on going. We got 2 more to find. All right, 2 comma something. So we're plugging 2 into the x, and we got to find the y value. Plugging 2 into the x spot, that's going to let us solve for y. So we have 2 minus 2y is equal to negative 6. Again, notice here, I'm replacing that x with 2, according to what we're trying to find right there. And now we can solve this equation for y. So let's subtract 2 from both sides. Negative 2y is equal to negative 8. And let's divide by negative 2, so we get y is equal to positive 4. Watch your signs right there. And now we have one more point. Something comma 2. So this last point on our t-chart, we want to plug 2 into the y spot. So let's do that. Going back to our equation, x minus 2y equals negative 6. But now we're replacing the y with 2, so we have x minus 2 times 2 is equal to negative 6. Solving this equation, we have x minus 4 equals negative 6. Adding 4 to both sides, we have x equals negative 2. So there is another point. We found all 4 of them. We filled in the missing values. You can just make a t-chart to the side, and I'll accept that. You don't have to go back and write them there. But these are our ordered pairs. 0, 3, that is going to be right there. Negative 6, 0 is going to be right here. Remember how to plot points. Those first 2 points that we found are actually the y-intercept and the x-intercept. But we're going to plot these as well since we were instructed to do so. 2, 4, so 2, and then 1, 2, 3, 4. I'm liking it so far. Notice these dots are staying on a line. And then negative 2, 2. So negative 2 up 2. Very good. Looks nice. All 4 of these dots will stay on the same line. So that will look something roughly like, I'll just start right there. Something like that. There's our line. So make sure we did everything. We filled in the missing values. We plotted those 4 ordered pairs, and then we sketched the line. So that's what I'll be looking for when I go to check your work on that problem. Number 17, graph using any technique of your choice. Now, I'm going to do just one technique per problem. What I recommend to do is to become, I guess you could say, fully proficient in this material. If you try different techniques, that's fine. Sometimes one technique is better than the other. For example, this equation right here, y equals 2/5 x minus 5. That looks like the equation y equals mx plus b. I would not do a t-chart. I would not do x and y intercepts. I would use my information, my knowledge of this. If we have an equation written like this, that negative 5, the b is the y-intercept. So we have our first dot that we can go ahead and put on the line. That m, as I mentioned earlier, the number in front of x, as long as y is by itself, that number there is the slope. So we rise 2, go to the right 5. So we do that from the y-intercept that we just plotted. So we go up 1, 2, and then to the right 1, 2, 3, 4, 5. So there's another dot. And that's really all you need to plot that line, but I'm also going to go down 2 and to the left 5. By doing that, it just gives me some more dots to work with. So when you grab your straight edge and draw that line, you can make sure it is as perfect as it can be. So something like that. All right. Now you didn't have to use the slope-intercept form of a line, which is what that is. You could have done a t-chart if you'd like, but hey, I like y equals mx plus b. This next equation, y equals negative 2. You're missing an x. I've talked about this in class. If you're missing an x, you either want to think Hoy or Vernox. In this case, we want to think Hoy since we have just a y. Cat's talking to me. But our y equals -2. So we're missing the x. We want to draw a horizontal line somewhere. And what most people like to do is they like to go to the y-axis and put a dot where y is equal to -2. But that is not the only spot where y is equal to -2. If we draw a horizontal line through that point, all these y values are equal to -2. Notice if we were to go and say, hey, let's find the ordered pair of that point. The ordered pair there would be 5, -2. Let me write that down. You probably can't read that. That ordered pair right there is 5, -2. Let's do another one over here. This would be -1, 2, 3, 4, 5, 6, 7, 8, -8, -2. Notice these points I'm writing down. -8, -2, 5, -2. This one right here was 0, -2. Something they all have in common, that y value is equal to -2. Now you don't have to plot those extra points as long as you can remember the shortcut I shared with you in class, and that was if you have y equal to some number, if you're missing an x, think about HOI, which means you need to draw a horizontal line. Alright, number 19, graph using any technique of your choice. Maybe you like getting y by itself. That's fine with me. We've done that already in several examples, or a few examples so far in this video, but I'm going to take a different approach. I'm going to use the x and y intercepts. You do not have to use this technique if you don't want to, but I prefer to because, hey, I know that we can plug in 0 for x. If you plug 0 into x, what that's going to do, if you plug 0 right there, that just goes away. So you're left with 4y equals 16. You can solve for y very quickly, so we get y equals 4. 0, 4. What we just found there is the y-intercept. So I'm using the technique of finding the x-intercept and the y-intercept to solve this problem, or to graph this equation. Now let's repeat this process, except now let's plug a 0 into y. If you plug a 0 into y, that 4y term goes away, so notice you are left with x equals 16. That's all we have left right there. Alright, I'm sitting here talking about doing that, and just as soon as I said it, now that I look at it, I'm like, okay, hey, we don't have a 16 up here on the graph, which is okay. I mean, 16 would be way over here somewhere. So the line is going to look something like this, but that's tacky. I don't want to see that when you go to graph a line. So let me change what I said. I'm going to still leave that dot right there on the y-axis, though, that y-intercept at 4, because watch what happens. Let's take the same approach we did up here. Let's get y by itself, except I know this equation that we did here, y was already by itself. But if we can do that down here, we can use that same technique of plotting the y-intercept and the slope. So therefore, we have x plus 4y is equal to 16. Subtracting x from both sides, we're trying to get y by itself. We have 4y is equal to, do not combine these, that's just -x plus 16. And then let's divide everything by 4. And when we do that, we get y by itself. So we have y equals, I'm going to write this as a fraction in front of x. So there's an understood 1 right there, which means we have -1/4 x, and then 16 divided by 4 is 4. Now notice I said, that the y-intercept was 4 back when we were doing the x-y-intercept technique. Well, hey, we still have it right there. No, ma'am. Woo-woo. Get off the table. Come on. No, ma'am. Hang on. Sorry about that. Notice we have the 4 for our y-intercept, just like we had a while ago. But now let's apply this slope, because we couldn't go all the way to 16 when we did the x-y-intercept technique. But what we can do here is we can go down 1, right 4. So from here, the y-intercept, we go down 1 and to the right 1, 2, 3, 4. And let's just do this a few more times. Down 1, to the right 1, 2, 3, 4. And if we went again, we'd be off the graph. But do you remember that red tacky line that I drew? It was going like that. We could go in this direction. We could go up 1 and to the left 1, 2, 3, 4. Make sure I didn't go up 1 to the left 1, 2, 3, 4. We do it again, up 1 to the left 1, 2, 3, 4. We're still on that same line. So when we graph that one, something like that. Make sure you're using a straight edge. All right, number 20. Determine whether the graphs of the equations are parallel, perpendicular, or neither. We need to talk about the slopes, and maybe we have to look at the y-intercepts too. So to do that, I'm going to get y by itself in both equations so we can look at the slopes. Because if the slopes are the same, recall in your notes and on other videos I've mentioned, parallel lines will have the same slope but different y-intercept. Perpendicular lines, look back at your notes there too, perpendicular lines will have slopes that are opposite reciprocals, and if neither one of these things occur, it'll be a neither. Well, let's take this first equation, let's get y by itself. Subtracting the 6x from both sides, we have 2y equals, do not say 2x, you cannot combine these. The only thing we can say is minus 6x plus 8, and divide everything by 2 to get y by itself. So we're left with y equals negative 3x plus 4. So that's that first equation. Let's do the same thing for the second equation. 15x plus 5y is equal to 21. Let's move the 15x over by subtracting. They cancel just like those back there did, even though I didn't draw a line through it. We're left with 5y equals, again, do not say 6. We cannot combine these, but we can say negative 15x plus 21. Divide everything you see by 5. And therefore we have y equals, negative 15 divided by 5 is negative 3x, and 21 divided by 5, you can leave it as a fraction, or you can convert it to a decimal. We don't have to graph this line, so it doesn't really matter to me. But what you should notice now, the slope of this line is negative 3, the slope of that line is negative 3. So these lines are probably parallel. But remember, two things have to apply for two lines to be parallel. They got to have the same slope, but their y-intercepts need to be different. And these two y-intercepts are different because 21 divided by 5 is not 4. So yes, these lines are parallel. All right, 21. Write an equation for the line described. Give your answer in standard form. All right, so that means we need to get ax plus by equals c. We want it to look something like this. However, I'm still going to take the same approach for writing the equation of using y equals mx plus b. In order to do this, we need to know some information. Well, we have a lot of information right here. To be quite honest with you, that point right there is the y-intercept. That point right there is the y-intercept, but you might be working through this and you might not recognize that it's the y-intercept. So let's just take the approach we've done in class. Let's plug in the y value of the point we have given, which is 3. Let's plug in the slope that's given, 2/3. Let's plug in the x that's given, which is 0. And then we're trying to find b. Once you do a couple of these examples, you'll start building a habit. Got to find b, got to find b. Well, the thing is, if we work this out, 2/3 times 0 is 0 plus b. Well, 0 plus b is b. So like I told you right here, if you didn't recognize it, that is the y-intercept. And notice we did get 3 for the y-intercept. So our equation in slope-intercept form is y equals 2/3 x plus 3. I forgot my x. Now here's the thing. If you left it like this, you are not following directions fully. I wouldn't count the whole problem wrong, but notice we do need to give this answer in standard form. So to do that, the a, the b, and the c, we want to get all integers and whole numbers, things like that. We don't want any fractions. So an easy way to get rid of the fractions here is to multiply everything by a common denominator. Since 3 is the only denominator that we have, if we multiply everything times 3, so let's multiply this by 3, let's multiply this right here by 3, and let's multiply this right here by 3. You don't have to show that, but you're just multiplying every term by 3. So 3 times y, we have 3y. If you multiply this by 3, what happens is that those 3's cancel out and you have 2. Or you can work this out. 3 times 2 is 6. 6 divided by 3 is 2. So we have 2x. Just be careful here. That's going to be plus 9. We're almost back to this form here. What we want to do now is move the x term over there to the y. So we'll subtract 2x from both sides. Do not combine those though, but what we can say is negative 2x plus 3y is equal to 9. Some people prefer to have that x term positive. It does not bother me. But some instructors may say, hey, that x term or the coefficient of x needs to be positive. That's not a big deal to me. You can leave it. As long as you get numbers that are not fractions, I'm happy. Integer coefficients is what these things are called, because these are integers. So that is standard form. Again, if you left it in slope-intercept form and you didn't complete this, you would not get full credit on that problem. So just make sure you follow the directions completely. 22. All right, write the equation for the line described. Give your answer in slope-intercept form. That means we want to use that y equals mx plus b. Well, that's what we use anyway to find equations of lines. So let's plug in the information that we have given. Let's plug in the y value. The y value is 4. Let's plug in the m value we have given, which is negative 9. Plugging in the x, which is negative 7. And then we got to solve for b, just like we did in the last example. So here we get 4 is equal to negative 9 times negative 7 is positive 63 plus b. Subtracting 63 from both sides, we get negative 59 is equal to b. And after several examples, we've done this in class and you've worked on this in the homework, we just go back and write this as y equals, we still use our m, so we have negative 9x, and now we bring this b into the picture, so minus 59. And just to throw this out there too, a way to check your work real quick is to just plug that point back in and see if it works out. Well, first of all, this line has a slope of negative 9, which meets that condition, so that's good. And then let's just hash this out one more time. If we plug in that negative 7 right there, negative 9 times negative 7 is a positive 63. 63 minus 59 gives us a y value of 4. And notice it does satisfy that point. Now 23, a slightly different approach. We're still going to find an equation of a line. So we want to use y equals mx plus b. But the problem is we're missing a little bit of information. Something to mention back here too, the reason why I stopped there because it said put it in slope-intercept form, so we didn't have to go any further than this. We can leave it in y equals mx plus b. The same thing is going to apply here. We're missing one piece of information versus what we had up here. This last problem, number 22, a slope was given to us. There is no slope given to you here, so we need to find that slope. The slope, we're going to use y1 minus y2 over x1 minus x2. So let's take our y values. That's going to be 2 minus 0 over, now take your x values and subtract them, 6 minus 3. So therefore we have 2 minus 0 is 2, 6 minus 3 is 3. Our slope is 2/3. Now from here it's entirely up to you which point you want to use. You can either use the 6, 2 or the 3, 0. Some students just like to use the first point, but some students actually sit there and look and they say, okay, which point's going to be easier to work with? Neither one of these are too bad to work with. So I'm going to use the 6, 2. We got to use that slope that we found. And now let's start plugging and chugging. So the y value, since we're using the 0.62, we're going to use the 2 for y, equals m was 2/3. Our x value is 6 in that point. And we're trying to find b. So we have 2 equals 2/3 of 6. 2/3 of 6 is 4, or you could multiply this out. 6 times 2 is 12. 12 divided by 3 still gives you 4. And then we'll bring our b down. To solve for b, we subtract 4 from both sides. So therefore our final answer is negative 2 is equal to b. Now let's write the equation. So the equation of our line is y equals, what was our slope? 2/3. So 2/3 x. And then our b was negative 2, so we can write subtract 2. Never hurts if you have a little bit of time to check and make sure both of these points work. Let's plug in 6 and 2 one more time. If we plug in 6 right here, 2/3 of 6, that's going to be 4. 4 subtract 2 gives you a y value of 2. Notice that 0.62 works. Let's plug in 3 for x and make sure we get 0 for y. 2/3 of 3. 2/3 of 3 is 2. 2 minus 2 gives you a y value of 0. So notice that point is satisfied as well in this equation. Just a way to confirm that we did it right. All right, number 24. Write an equation for the line described. Write the equation in the form specified. We want to write this equation in standard form. So that's going back to that ax plus by equals c. Get a swallow a drink real quick. And we want this equation to be perpendicular to this equation. That right there is going to help us because we know what slope to use. We know what point we got to use. We want the line to go through that point. So that's going to be our x and our y that we use in a minute. But we're missing our slope. But since it's going to be perpendicular to this line, let's get y by itself. We've done this several times in this video now. Be careful, do not combine those. Do not say 48x. And just going through the motions of getting y by itself. So we have y equals positive 2/5 x minus 10. The reason why we got y by itself in this equation is because we want to not necessarily use the slope, but this slope is helpful. We do not use 2/5 for our slope though, because we want to find a line that is perpendicular to this. Remember, for it to be perpendicular, we want to use opposite reciprocal. So the point that we have, 5, 8, we're going to use that. The m that we want to use is the opposite reciprocal. And in class, I mentioned opposite reciprocal means change the sign so it becomes negative, since this was positive, and flip your fraction. So negative 5/2 is the slope we want to use, because we want to find a line that is perpendicular to this one. So let's do that real quick. We have enough information to do our y equals mx plus b stuff. Let's plug in everything. The y value is 8. Our m that we want to use, remember, the perpendicular slope, so negative 5/2. Our x value is 5. And then we have plus b. We want to solve for b. All right, we got a fraction here. This fraction, so we have 8 equals, multiplying this, negative 5 times 5 is negative 25 over 2 plus b. And let me move this stuff out of the way. Need some more room. And to get b by itself here, so what we need to do is add that 25/2. Some of you probably converted this to a fraction. I'm not going to, because I'm pretty comfortable with dealing with fractions here. But 8 plus 25/2, we can't do that. So therefore, we need to actually think about this as being 8 is 16 over 2 plus 25 over 2. Therefore, we get what here? 16 and 25, that's going to be 41 over 2 is equal to b. Because notice we did get b by itself by doing this. Now, you don't have to show all that work either, but 41 over 2, if you're going to use a decimal, I don't recommend it because we're going to have to use these fractions to help out in a second. But 41 over 2, that's going to be the same thing as 20.5. If you were checking that in the calculator, I don't mind that. So what's our equation in standard form? Well, we got to get there. We got to build up to that. So our equation right now is y equals, the slope was negative 5/2. So we have negative 5/2 x plus 41/2. Now this would be okay if we could leave the equation in slope-intercept form. However, we need to convert this to standard form according to the directions given above, right there. Convert it to standard form. So a way to do that is to get rid of our fractions. The way to get rid of fractions is to multiply everything by a common denominator. Our common denominator is 2. So if we multiply by 2 here, we get 2y. Multiply by 2 here. The 2's will cancel, you're left with negative 5x. And multiply this by 2 here, you get plus 41. And now from here, let's get the x and the y on the same side. That's what standard form means. So we want to add the 5x to both sides. And therefore we have finally 5x plus 2y is equal to 41. There is our standard form. And last but not least, number 25. The total sales made by a salesperson was $25,000 after 3 months and $68,000 after 23 months. Predict the total sales after 45 months. Alright, so for this one, I'm going to set up some ordered pairs. I'm going to let the X represent the months. So at 3 months, the sales were at $25,000. And that's total sales. So obviously this number is going to increase as time goes on because we keep on adding sales on top of what we've already done. This other ordered pair is 23 months. The sales were at $68,000. So we have 2 ordered pairs. We want to predict the sales after 45 months. We need to find an equation using these 2 points. Well, to find an equation, we need a slope, and we need a y-intercept and all that stuff. So we're going to go through the same motion, y equals mx plus b. But we need to find m, that way we can plug it into here. So let's find m using these points. M equals, let's take our y values and subtract them. I'm going to go this way just to get positive numbers. So we have 68,000 minus 25,000 over 23 minus 3. So really what I'm doing here is I'm taking like a y2 minus y1 over x2 minus x1. 68,000 minus 25,000, that gives us 43,000 over 23 minus 3, that's going to be 20. And let's divide that. 43,000 divided by 20, we get 2150. That is going to be our slope. That's the number we want to plug in right there. And now let's come in and let's plug in either one of these points. I recommend using the smaller point or smaller values, just easier to work with, I guess. So the y value would be 25,000. The x value from that point was 3. And now we can solve for b. And you can use the calculator here to speed through this. I don't want to see all that scratch work. I'm okay without seeing that. So we have 25,000 equals 2150 times 3. We get 6,450 plus b. Let's subtract the 6,450 from both sides. And therefore we get 18,550 is equal to b. So our equation is y equals 2150x plus $18,550. Now, what does this equation mean? Well, we're going to answer the question. We're going to predict the sales after 45 months. Well, notice I let x be 3 months. Here, I let x be 23 months. The idea is this. Since we let x be the months, we want to plug 45. Since that's 45 months, you want to plug it into x. And then y is going to be the sales after 45 months. So we have y equals 2150 times 45 plus 18,550. And go ahead and crunch all that out. So 2150 times 45 plus 18,550. We're looking at y equals to $115,300. Remember, this is a real world problem, so give me a complete sentence. The total sales after, 45 months is predicted to be $115,300. Now, there is the answer. Just to look a little bit deeper into it, what does that 2150 mean? Well, back at 3 months, they were at $25,000 in sales. And as time went on, the total sales means they keep just adding the sales on top of the other sales. So it did increase up to 68,000. When we use these numbers here to find the slope, that number right there means that salesperson, on average, because this is, I mean, we're predicting here, but they were making sales of around $2,150 per month. And notice we took $2,150 per month times 45 months, and then plus this y-intercept that we found. That's how we came up with that number. So that's just another application of that slope too. This salesperson is selling $2,150 or making sales worth $2,150 per month, and we multiplied it times our number of months. What does that $18,550 stand for? It's a y-intercept. That would represent the amount of sales made at 0 months, which can be kind of weird to think about, but I mean, hey, we had to go through that same motion of finding B. At month 0, if you were to plug 0 into that, there will still be $18,550 in sales. But I got on a little tangent there. The final answer that you want to get is that. So all 25 problems for your DMA 50 review. If you can do these problems, I assure you you'll do just fine on your module exam. Don't waste time asking questions. Make sure you look at this, not at the last minute. And that is it for this video. Hope it helped.